Good day, everyone. I welcome you back to Global Education Zone, the home of impactful learning. It's nice over here for you and I because learning never ends and education is the key to an impactful life. Everyone, I welcome you back to Global Education Zone, and today we have come back to another episode of our Crash Mathematics for SS2 course. And in this episode of this course today, we are going to be talking about transformations. Now, transformations, they are very important part of Cartesians, planes, and geometry, and we are going to be talking about them today because you need the knowledge of transformations in order to further your knowledge in mathematics. So now, a transformation, in literal terms, transformation simply means a change. When you change, that's simply what it means. It's just change. But now, when we come to mathematics, it doesn't just simply mean change. It means a kind of change. It's a kind of change that occurs in the coordinates of points. Now, when you change the coordinates of a point from one place to another, you have performed a transformation in mathematics. Now, before we talk about the examples and illustrations, let's talk about the concept, what transformation is all about. Now, in this concept, we are going to be dealing with, first of all, a transformation is when a shape changes to give a new image. Now, let me show you what. Now, to make you understand transformations better, let's talk about the different types of transformations that we have. Now, there are transformations that are called translations. Yes, there are translations as transformations, there are rotations as transformations, and then there are reflections as transformations. Now, these three is what we're going to be focusing on in this video. So there are still more, but these are the three that you will need to understand for this basic and first episode in transformations. So now you can see that in this diagram here we have a transformation of the triangle ABC to the triangle A complement, B complement, C complement. Now when something like this happens, it means that the position or dimensions of both shapes have been changed. So the position or dimensions have been changed. So you can change the position, you can change the dimension, or you can change both. So when we change such, it's called a transformation. That means the original shape, which is ABC, has been transformed to a new shape, A complement, B complement, C complement. And the image is the figure which results after transformation of the shape. So that means you can see that the image, after we transform ABC, triangle ABC, we get a second shape, which is A complement, B complement, C complement, and that becomes the image of the shape. Now, a transformation is like a mapping. So in a particular episode in this course, let's call it in this channel, I talked about mappings. The fact that mappings are basically is a relationship between an initial state or initial function and a final state or a final function. So that's simply what a mapping is. A mapping is just like a web, just like the internet, just like when you connect a computer to a server. That's kind of like a mapping. That program that is used to connect those two devices is like a mapping. So a mapping is just like a computer program that connects your computer to your server and your server to your computer and so on and so forth. So and transformation is just like a kind of mapping like that. And you can see that in this shape, you can see that A maps to A complement, B maps to B complement, C maps to C complement. And in that case, triangle A complement, B complement, C complement is the image of triangle ABC. Now, if you want to have a more grounded and full knowledge of mappings and transformations, you can check out my video which I've made on transformations in this channel in furthermore. Just check it out, and then you can easily understand better about what mappings are, and then you can use that knowledge to apply it to understand transformations. But still, I will still make further videos to explain this concept more. But let's continue. Now let's talk about translations. So translation is basically when you move a point in a straight line. It is a movement in a straight line. When you translate a point, it has been moved from an initial position to a final position, and the force or what has translated it will be a linear pull. So what has translated that point will be linear. So it is a linear direction. What translated it will be linear. So for example, you can see that here we have points moving in linear direction. So linear can be in a straight line, in a straight horizontal line, or in a straight diagonal line. So but it is a linear line that has been translating those points. So now let's talk about under a translation. Every point in a line or plane shape move the same distance in the same direction. So whenever we translate a something, every point in that line, every point in that plane, in the line of plane will move the same distance in the same direction. For example, you can see that in this example here, we can see point P 2,3 has been translated to P complement 5,7, and that line P complement that joins P to P complement, that line is the translation vector, and that translation vector is represent the distance and direction. So when we translate a shape, every vertex of that shape will be moved by that same translation vector. So it's just like you are kind of adding the translation vector to that shape. So that is simply what we'll be doing in this video. We're going to be adding translation vectors to their initial positions to get the final state or the transformations of those initial states or shapes. Now moving on, we have to explain that more, we have the position vector of P, which is 2,3, has been translated to P complement, which is 5,7, and the displacement vector is 3 and 4. That's 3 for the column vector 3 and 4. So in the previous video on vectors, I talked about column vectors, how they are represented, and this is the column vector 3 and 4. So it is 3 units in the y-axis and 4 units in the g-axis if you are representing it as row vectors. Now this P complement, you get it when you add the transformation vector to the vector P. So that's 2, 3, the vector 2 and 3, when it has been transformed to the vector 3 and 4, it will give you 5 and 7. So that vector 2 and 3 has been added to vector 3 and 4 gives 5 and 7. So that is how you get the transformed vector. Now the translation, this is how it's notated. You just represent it as T has been transformed. T has transformed to 3 column vector to 5, 7 column vector. So that is how transformation looks like. And in general, if the position vector with point X and Y column vector is given a translation A and B column vector, that means the position vector of its image will be X plus Y and Y plus B. That will be the new image. So you are basically adding those vectors together. You are adding the initial vector and its translation to get the translated position. Now that's how it works. So now for this translation, let's work on an example 1. So the vertices of a quadrilateral A, B, C, D have the coordinates. A is minus 1,3, B is 1,4, C as 2,3, and D as 1,2. So we have to determine the coordinates of the image of A, B, C, D under the translation 4 and 2. So this translation column vector is represented by 4 and 2, and here we have under T the A column vector is minus 1 and 3. So we add the translation vector, which is 4 and 2, the translation column vector 4 and 2 to that A coordinates to give finally we get 3 and 5. So we keep adding the translation column vectors to each of the vertices of that quadrilateral. So at the end of the day, we'll get the resultant coordinates of the translated vertices. So and then when we join those vertices together, as you can see, the coordinates of the vertices of the images are A complement 3 and 5, B complement 5 and 6, C complement 6 and 5, D complement 5 and 4. So as you can see, that's how it works. So that is how translation works. So and if that comes around, all you need to do is you just add your translations vector to your initial position or your vertices. So you are going to get your final or transformed position. Now that being said, for translation, let's go on to another type of transformation, and this is known as your reflection. Your reflection is the image you see when you look in the mirror, right? So when I look in the mirror, and even when I'm looking at the camera right now, I'm seeing my image, right? Now that reflection, it is what you see when you look at your mirror. But this time around, we are talking about your point. So when you reflect a point, it is what that point looks like when it is standing in front of a mirror. So that's how it looks like. So now the reflection in the line of the mirror is a line of symmetry between the object shape and its image. So it is like the line of symmetry that is equidistant from the object and its image. So you are going to, that means the distance from the line of symmetry, that is that line of the mirror, the distance from the line of symmetry to the point will be equal to the distance of the image of that point to the line of symmetry. For example, you can see that in this figure where we have the dashed line, the dotted line as the line of symmetry or the line of the mirror. So you can see that the point P has an image Q. So that image Q is on the opposite side of the line. So they are on opposite sides of the line of symmetry. And anytime you are asked to look for the reflection of the line, this is simply how it works. You just have the opposite line on that line. So there are different methods for looking for reflection. For example, this is a table. You can see that the reflection of P is Q, the reflection of Q is P, of P is Q, of Q is P. So you can see that we are getting the alternate reflection of each of these of these um of these shapes. So the reflection of P is Q. So on the first row, we look for the reflection of successive elements. So that's the first element. P has a reflection of Q. Element Q has a reflection of P. P in turn has a reflection of Q. So then for the second row, we have B has a reflection of D. D in turn has a reflection of B, so on and so forth. So that's how reflection works. So now let's talk about reflection in the x-axis. So what if you reflect a point in the x-axis? Now you can see that if you reflect a point in the x-axis, you are going to be looking for the negative of the y coordinates. So that's what it means. So that means if you reflect a point in the x-axis, that means, and that point is point x and y coordinates. So that means that that reflection will have a value of x and minus y. So that is how it works. So but if you reflect in the y-axis, you have a value of minus x comma y. So when you reflect x comma y in the y-axis, you have minus x comma y. That is how it looks. So for example, if you reflect the point 2 comma 1, we'll get minus 2 comma 1. So then last, let's talk about the reflection in the line y equals x. So this line y equals x is a line that goes in between the x and y axis. It is kind of like the bisector of the angle between the x and y axis. Now in this reflection, what we'll be getting, if we're reflecting a line p which is 2,5, the reflection of that line will basically be the interchanging of the x and y coordinates. For example, if you reflect the line 2,5 in the line y is equal to x, you get a coordinate of 5,2. So just interchange it. 2,5 will change to 5,2. That's how it looks. So if p is 2,5, so p complement, or the reflection of p, will be 5,2. Simply interchange. So this is real, this works, and this is, no matter what point you have, you can try yourself. You can draw draw the line y equals x, draw it as a graph. You can just plot up values and draw it, and then you can pick a point on one side of that line, and then look for the reflection of that point. So basically, you just draw a straight line, perpendicular line from that point to the line to the graph y equals x, and then you are going to mark a point behind that line, behind the graph y equals x, and that point behind will be equal to the distance from that point p to the line y equals x. So it will be behind it, and then you can also use that to get the coordinates of the reflection. So that is basically how reflection works. It's just the opposite of that thing you can see. It's how it looks like when it is behind a mirror. Now, so that being said for reflection, let's talk about this example. If a point P has the coordinates 5, minus 2, find its reflection in the x-axis, the y-axis, the line y equals x, and the line y equals minus x. Now you can see that this is number A. We have in the x-axis. All you need to do is just look for the negative of the y coordinate. So that will be, if you are reflecting y 5, minus 2 column vector, then you get it as 5, 2. But in the y-axis, you just find the negative of the x value. That will be, if you're reflecting 5, minus 2, you just look for the negative of the x. That will be minus 5, minus 2. Then number 3, if you're reflecting in the line y equals x, you just simply interchange your coordinates. That means if you're reflecting minus 5, if you're reflecting 5, minus 2, you will simply change it to minus 2, 5. You change the x and y coordinates. So, and then lastly, if you're reflecting the line y equals minus x, so simply all you need to do is you simply change the coordinates, and then you multiply by minus 1. So you change it. So that means if you're reflecting from x, y, you change it to minus x minus y, minus x. So that is how reflection works. So you can see that reflection is basically involving mirrors and lines of symmetry. Very simple. Once you grasp the basics from what we've discussed so far, you find it very easy to resonate with the concept of reflection. Now that was the second part on transformations, and the third part and the last part we'll be talking about rotations. So rotation is when you rotate a line or rotate a point about an axis. So you have to rotate about an axis, and then you get the next value. So now let's talk about rotation. And these rotations, and just so you know, in a subsequent video, I'll also be using this concept and taking them further into in our further mathematics classes, which I hope to do in subsequent videos. So you can always check out for those videos where I'll be talking about subsequent topics in mathematics and so on and so forth. Now let's talk about rotation. Rotation is another word for turning. When you turn, you get the rotation. For example, you can see in this diagram when we turn the p, when we turn the p, which the first, which is at the top, when we turn it to the left, when we rotate it left, we get a p, that's p. When we rotate it downwards, we get d. Then when we rotate it right, we get a p that is facing down. So that's how the p is rotated. When you rotate any line, any point, you rotate it about an axis. So basically, the small cross, we have a small cross, and that's called the center of rotation. So that small cross in between the p's, they are known as the centers of rotation. Now this is how rotation works. So we just rotate a point or a group of points around a center of rotation, and then we'll get our new point, and that center of rotation is also known as the axis of rotation. Now let's try an example here. If the point p is equal to 2,4 is rotated anti-clockwise through 90 about the origin, determine the coordinates of the image. So in this example here, we have a point p, and this is the coordinate 2,4. All you need to do is you draw a line at 90 degrees, you rotate anti-clockwise, and then you draw the corresponding line. Then you that OP, the length OP will be equal to the length OP complement. So that means they will be equal in length, and then you read up your coordinates. That will be, when your P is 2,4, your rotation will be minus 4,2. That's how it works. So that's how rotation works. And for example, let me give you shortcuts for rotation. When you rotate clockwise, when you rotate a point clockwise, when you rotate a point x, y clockwise in 90 degrees, you get a new value of y, minus x. When you rotate 180 degrees, you get a new value of minus x, minus y. When you rotate 270 degrees, you get a new value of minus y, x. And then when you rotate 360 degrees, you still get again x, y. So that's how it works. So there are formulas for this, and there are derivations for this formula, and we'll be talking about this in depth detail in the classes I will be holding in further mathematics. But for mathematics, this is just what we'll be doing. And this transformation, they can also be expressed as matrices. So and these matrices, we'll be talking about them in subsequent videos. But thank you for being with me in this video so far, and don't forget to like, share, and subscribe. Thank you for watching. See you next episode.